there are really only two things, two different categories of things here. One is, can you find a given term if you're given a formula? For the test, this one said find the 10th term, okay, which means find A10. Okay, that's the 10th term. There are two pieces of information here, and you need both of them to get where you want to go. This is a recursive formula. If you want the 10th term with a recursive formula, you've got to work for it. Okay? A1 is equal to 1/5 because it says so. A2 is equal to 1/5 plus 5/3. Okay. A3 is equal to 1/5 plus 5/3, right, whatever that turned out to be, plus 5/3. A4 is going to be 1/5 plus 5/3 plus 5/3, because that's what came before, and then you have to add 5/3 to it. At this point, you probably start to see a pattern. Okay. Here, you've got 1/5 times 1, I guess, right? Or plus 0. 1/5 plus 0. Here, you've got 1/5 plus 5/3. Here, you have 1/5 plus 5/3 two times. Okay? So for the first one, you had 1/5 plus 0. Then you had 1/5 plus 5/3. Then you had 1/5 plus 5/3 twice. Here you have 1/5 plus 5/3 three times. And I could keep going on with this, but there's a pattern here that starts to emerge. Okay? Basically, you have 1/5, right, plus 5/3. How many times? Well, it depends on what number in the sequence you're looking for. If you're looking for 1, it's 0 times. If you're looking for 2, it's 1 time. If you're looking for 3, it's 2 times. If you're looking for 4, it's 3 times. Every time you're looking to multiply this by something, you're going to be multiplying it by the number term you're looking for less 1, the one just before it. Yeah?
For A2, you said it's 1/5 plus 5/3.
Mm-hmm.
So you would say, and the equation would be like A2 equals A2 minus 1, which is A1.
Yep. That's exactly right. And you'll notice that in doing this, take a look at this, right? Moving from this recursive formula, we now have this. This is an explicit formula. Okay? And that means if you want A10, you can plug it in. You can plug 10 in. 5/3 times 10 minus 1, and then just do the arithmetic. It's 1/5 plus 5/3 times 9, which is 1/5 plus 5 times 3, which is 15, and 1/5. And that is A10. And so you really had a choice here. You could either turn this into an explicit formula and then use it, or you could sit and go through step by step by step by step 10 times until you got what you needed. This tends to be a little harder. Anybody have a question about what to do with that? Yeah.
It seems like it's easier for you to first make a recursive formula and then use that to make an explicit formula.
Well, we were given a recursive formula,
Oh.
right? So we turned it into an explicit formula in order to use it. Because, yes, if you're looking for a specific term, it's much easier to have an explicit formula because it explicitly tells you what the value of that term is.
For the explicit formula, do you have to write times n minus 1 or times n?
It depends on what the formula is. In this particular case, right? In this particular case, it's n minus 1. Why? Well, because that's what's happening. And the thing to remember is, all of this works for us. We don't work for it. This is supposed to express what we have figured out. Okay, there's a sequence somewhere. In this case, we don't have it. We were given the recursive formula. But this is the story, this recursive formula. And this works out this way. Right? If n is 1, we're not adding anything to 1/5. If n is 2, we're adding something once. If n is 3, we're adding something twice. Every time we add something, we're doing it as many times as the preceding term was. Okay? So that, in this case, that's how you write this out. Okay? This needs to reflect what the story was that you're writing. This one is an explicit formula. Because when you're defining an, you're not mentioning anything that came before it. You're just going straight to what's the value of this going to be. So if you're looking for the 10th term, it's going to be minus -3 times 10 minus 1. It's minus -3 to the 9th. And that would be -3 times -3 times -3. If you're wondering why is he doing this, it's because in order for me to figure out how much this is, I don't want to just sit and multiply everything by 3 over and over again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? I know that this is going to be positive 9. And this is going to be positive 9. This is going to be positive 9. This is going to be positive 9. And this is going to be -3. So that helps a little. This is going to be 81. And this is going to be 81. And this is still -3. So this is negative this times that. And that simplifies the problem a little bit. Yeah.
Is the one above it, a to the n equals that? Is that explicit formula? Or
That is an explicit formula because it tells you exactly what the term is going to be without referring you to the term that came before.
So would that the bottom one be an implicit formula?
I'm sorry?
Would the bottom one be
If I wanted to write this as a recursive formula, I could rewrite it. If I want n to be 1, if I want to know what the first term is, right? I would substitute 1, and that turns out to be -1. After that, what happens? If I want a2, it's going to be -1 times -3 to the 2 minus 1, right? And then after that, it's going to be a3 is equal to -1 times -3 to the 3 minus 1. Basically, what's happening here is for each one, I'm taking the one that came before and I'm multiplying it by -3 again. For each one of these, I'm just multiplying it by -3 again. So it's, right, a1 is equal to -1, and then all the others are -1 times -3. But this, we weren't asked at this point to figure that part out. Right? We were asked to figure out what the 10th term is. So all we have to do now is multiply 81 times 81, and then multiply that by -3, and then take the inverse of that. So that's how to find the term, if you're given, whether you're given an explicit formula or a recursive one.